Hey guys, what's up? Welcome to my channel and welcome to part 2 of the how to start 3D printing series I've been working on. If you've made it this far, it's probably because I didn't scare you away with the first one. So thank you for continuing on and actually wanting to learn more about 3D printing, the printer and the hobby and the software and just how to get started. This video is going to mostly be focusing on the printing hardware itself. What makes up a 3D printer, and hopefully by the end of this you guys will have a little bit of a better understanding of what's actually happening with the printer itself. How is the plastic filament melting and making its way through the printer to actually make a print on the bed that you can then take off and hold in your hand. I got done with this last night actually, Stormbreaker, and I love this thing. I could hold this in this entire video, but we're not going to do that. And please don't mind my no-armed compatriot standing back here. The stand is having some difficulty issues, but yeah. So this is going to be a little bit of a different video. I see a lot of videos out there where there's somebody standing here, right? And they're like, well, this is this, and this is a printer, and if you look here, and you can't see anything. And they might do, B-roll clip shots and zoom-ins, but I want to try to do this in more of a first-person view because I want you guys to feel like it's you doing it and it's you standing here looking at the printer. So we're going to go to a kind of a first-person view. I'm going to be holding the camera. I apologize if it's a little shaky. I do have a stabilization gimbal. I'll try to do the best that I can, but I want you guys to see what I'm seeing as I'm explaining it and going through the parts and components. We're going to look at everything. I'm going to make sure to note some of the things you might encounter out of the box. There's going to be some loose parts, your bed's not going to be level, so we're going to talk about that, and hopefully by the end of the video, we'll also pump out our first little test print on this. This way when we move to the next video, software, the printer's all set up, ready to go, and we can actually start printing this little helmet that we talked about in the first video. So let's get started. So you built your 3D printer, it's sitting on your table and you're looking at this thing like, what did I just get myself into? You could have went with an Ender 3 that looks like this. You might have gotten some type of all-in-one printer where it's actually assembled out of box, or you got something like an Anet 8, and this is a 100% DIY printer. This is kind of what started the craze, and you literally build everything, every nut and bolt and frame, and you run all the wires. This can be a little bit of a deterrent for people, but this is kind of what started the entire hobby, and it was these build-it-your-own printers that really sparked this whole revolution. Now you can have these type of printers for about $200 to $300, or you can get a little bit crazier and get bigger printers like this. All of these printers do the exact same thing in basically the exact same way. They're just built a little differently. So I can sit here all day and name every single part and tell you everything it does, but we just don't have time for that right now. I want to explain to you what's happening on this plastics journey, starting up here on this roll and getting all the way down to a coherent print. So right off the bat, I need to say that if your printer came with a little pack of filament plastic like this, your print's probably gonna come out kind of bad. This filament sucks. So if you're getting bad print quality, hopefully when you ordered your printer, you got a new pack of filament like this. All you're gonna look for is just PLA plastic. And that's what this is, PLA white plastic. I've already gone through a good amount of the roll. I have just enough left probably to do a couple little prints. So you have your filament up here. But what's actually gonna happen to this filament as it travels through the printer? Sitting right back here is your extruder. And you can usually pick these out because they'll have a nice little metal spring, they'll have a little gear, and they'll have a tube coming out of them. Now, if your printer doesn't have this type of tube, this is called a Bowden tube setup. Your printer might be a direct drive setup, and that actually looks like this. So this doesn't actually have a tube on it. That extruder is mounted right here above your nozzle. So it doesn't have that white long tube, and I'm going to explain kind of what that is on the other printer, but just know that some printers might not have it. So your extruder and extruder gear is what actually extrudes or pushes your plastic. So if I was to take that gear off, this is what it looks like. It has some teeth on it, and it's pushing against this silver bearing, and as this gear spins right here, it's actually forcing filament through this white tube, and it's going to go all the way through this tube into your hot end and your nozzle. This is your nozzle. This is a pretty standard nozzle on all of the Creality type printers, and they look similar across the entire 3D printing world. Here's this white tube again, and it's going to push the filament through this white tube. Now this is your heater block. This is your hot end and your heater block. And if you actually look, if I take this sock off right here, this will probably be on your printer too. It's going to push this filament through, and this is a heat sink. So all these little fins right here are having air blown through them from the fan that's on the front of the printer. This fan right here. So air is getting blown through this because this little hot block right here, and you can actually see on the side, these thicker red wires are heating up this little block and making this get to about 200, anywhere between 180 to 240 degrees Celsius. Don't touch this. And what that's doing is it's heating up this super tiny little nozzle, and this heat sink block is, and the air going through it is stopping the heat from traveling up this tube and melting the filament too early. Because if the filament starts to melt too early, you're going to get a weird clog and you're not going to be printing. So the heat doesn't want to travel up this block. It wants to stay right in here. And as the filament travels through this tube, it's cold, 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 starts to get hot, hits this block, and gets pushed out as melted plastic. Now, as this plastic's coming out, you'll notice there are actually two fans on this hot end. So this is the fan that's going through that heat sink and making sure the heat doesn't creep up into this tube. It's literally called heat creep. And then this fan right here, there's a little air duct sitting right at the bottom here, and it's actually blowing air across the nozzle right here. Let me take this off so you can get a better look. So the block on the other one was copper, this one's silver, same thing. So it's blowing air right across this nozzle. So as the print comes out, it's cooling it down as fast as possible. So the plastic isn't actually melted all that long. That's really how 3D printing works. It is an extruder gear pushing the plastic through into a heat block and then melting. Now I said these red wires are heating up the block, right? These white wires here on the side are actually a very tiny thermometer held on by this screw. It's a little glass thermometer. And what that's doing is it's talking back to the printer to let the printer know this is the temperature of this block. Because if the printer had no idea what this temperature was, it would keep heating and heating and heating. And that's actually called thermal runaway. That's for another video, and it's actually a cool little feature that these printers do. So this is talking to itself. Heating, heating, heating. The thermometer will say, hey, it's hot enough, stop heating. So that's how it determines the heat of this block. So that's literally how 3D printing works in a sense. This is its own system. The rest of the printer just helps move this around or have this moved around. Now, like I said, if you don't have this white tube right here, it's because you have a direct drive setup. So this is how the plastic's getting melted. This gear is spinning, that's cool, it's pushing it through, but how are we actually gonna get a print out of this? The rest of the printer is doing the job of making sure that this nozzle and this bed get moved around in an orientation to actually make the print. Because if I was just to turn this on right now, we would just have plastic dripping out of this nozzle and nothing would be happening. So we need to be able to move this nozzle left and right, up and down, and then we need to move the bed in and out using the same type of stepper motor. This is a stepper motor. It moves in very precise degrees or steps. It's not so much a brushless DC motor that just spins freely. It actually almost has gears and clicks in it. So it knows to move in very tiny, tiny millimeter sized steps. So this is your extruder stepper. This is your X-axis stepper, which will move a belt, which you can see moving right here. And that's what's pulling this left and right, your X belt and your X stepper. When the X-axis gets to this little trigger switch right here, it knows to stop. So that's 0. Now your bed does a very similar thing. It moves in and out, again, on a belt system or a rail system. In this case, it's actually on a guided rail system along with a belt. So this moves in and out. And again, right back there is your Y stepper motor and your Y end stop. So when my bed moves all the way back, it clicks and it knows to stop. That's 0Y. Now your Z Gantry, the whole gantry that moves across here, this can be in a little bit of a different fashion. There's actually another stepper motor right here sitting, and what this does is as this spins up and down, it actually moves your gantry up and down, and then you have your Z stop switch. So let's move this all the way down. Don't do this, by the way. I can't believe I didn't say this earlier in the video. You don't want to go by and just move your printer back and forth. I've unplugged all of my stepper motors because since these do have electrical conduits in it, as you spin them, they create electricity. And if you actually plug all these in and move your bed fast enough, you'll actually see your printer power surge and turn on. It's not the best for the printer. So I've actually gone through and unplugged all of my stepper motors so I can actually move my printer freely without having to worry about this. So don't move them around haphazardly like I am. As we move this down, it's gonna click right there. And now that's 0 Z axis. So right there, the printer would know that the nozzle is at 0, X, Y, and Z. And with those coordinates, like a CNC router or any type of CNC machine, it will know to move up, or it wants to move up, it wants to move over, it wants to move out. So it'll typically start your print in the middle of your bed, however you positioned it, and you can hear it click. And what it'll do is if we were to make a box, it would go this way, there, and back. And then the stepper motor would step up 1 millimeter or however high it needs to. It would go up again and it would rinse and repeat and do the same square again. If I had filament dripping out of this, I could theoretically be 3D printing right now. It would be the worst box you've ever seen, but that is all that the printer is doing. It's moving everything in a coordinate and in such a way to make one layer.
and then it'll build up a next layer, and so on and so on. A 3D printer is basically a really advanced hot glue gun, a couple motors, a couple belts, and a bed. That's really it. But now, let me talk about the bed. The bed is very, very, very important. Now, your bed might look a little different than this. This is a solid fiberglass bed. Your bed might have came with a real glass plates, or it might have came with this really cool magnetic flexible bed. Whichever the case, the bed is probably the most important part of the printer next to the actual extruder melting the plastic. I want you to picture this for a second. My nozzle head is sitting right here, correct? Very close to the printer, and it wants to push out filament. And then it moves all the way to this side. But for some reason, this bed isn't level with this rail. Now this nozzle is going to be too far or too close to the bed, and now it's either going to be way too far away, or it's actually going to hit and scrape the bed. If your nozzle's too close, filament can't come out, and if it's too far away, the filament's not going to stick. Leveling your bed is kind of a nightmare, or it can be the easiest thing you can do. There are tons of videos on how to level your beds, how to level each individual printer with each individual type. So I can't make this, it can't be a bed leveling video, but all you need to know is that that distance right there is crucial. The way I level a bed, and what you'll see online, is actually using a piece of paper or a sticky note. And the distance from the bed to the sticky note should just scrape. And if it just scrapes, you're pretty much level, but you want to do this when everything's heated up. So having your bed level is very crucial, and what you'll do is you'll do all 4 sides. You'll do each corner and make sure this is perfectly square and flat to the whole printer, because if all 4 of your corners are perfectly level to that nozzle, theoretically, the center of your bed is also going to be level. So there are some printers that actually have a cool little sensor that actually helps level your bed for you. So you're still going to go through and do all the same little leveling with the adjustment knobs, but this will help dial in and tell you what is actually on level without you having to do any like paper tricks. So you kind of understand how bed leveling works, making sure not level to like the table or the surface you're on. It needs to be level to this actual rail system, the X and Y coordinates. Once your bed's level and you have filament loaded, you're pretty much ready to go. And we're gonna move into that in a second, but I wanna talk about a couple things that might actually be loose or wrong right when you get your printer. Now, again, these are kind of DIY assembly printers. They can have problems right out of the box, and that's to be expected. There's a lot of them moving around. There's a lot of companies making them. A few of the biggest problems I've seen on Creality printers or Annette's or Artillery's, first thing that you're probably going to notice and you're going to want to check, is your bed wobbly or is your nozzle wobbly? Now, right off the bat, these can cause print issues that will just absolutely drive you up the wall. And unfortunately, they're a little bit hard to isolate if you don't know what you're looking at. So the first thing you're going to want to do is grab your whole nozzle gantry and try to wobble it back and forth. And you're gonna actually see these bearings moving back and forth. If this is wobbling back and forth a lot, you need to tighten this up. Now, if you look up here, you can see this bearing and the roller, and there's a round spacer on each side. But if you look at the bearing that's underneath it right here, it actually has a hex shape to it. So this is actually a concentric nut. And what this means is that there's a hole going through this spacer that's not centered. So as you actually adjust and put a wrench on this nut and turn it left and right, it's actually going to spin this bearing around and put more pressure on the actual rail system. So if this is all wobbly, you're going to want to put a wrench on this and adjust it very slowly until the wobble goes away. But don't over tighten it. You still want it to be able to move because the motor is going to be doing this, but you don't want it so tight where it's actually struggling. The other problem might be your bed is loose in the exact same fashion. So as this was wobbly because that bearing was loose, the bed actually travels on 4 to 6 little rollers in the same type of setup, where the bearings on the other side have round spacers. These ones have these little hex concentric nuts again. So again, you're going to tighten them up until the bed no longer wobbles. I can promise you right now, 99% of the problems you're gonna have with 3D printing is because you have some loose hardware. The G-code and the programming and the software, they're easy. They do the job for you. People have spent a lot of time programming those things to get them to work. If you're having print trouble, and I know some of you have probably heard it, it's probably because your bed isn't level. But it's not just your bed being level in the sense to the nozzle. Is your bed loose? Is this loose? A well-built printer will make nice smooth prints almost every time. But if your printer's not assembled right, it doesn't matter how good your code and programming is, your print isn't going to come out right. So taking your time to understand the printer, make sure that your belts are tight, and you don't want them to be guitar string tight, but you want them to be nice and snug so the gears don't skip. Making sure this is nice and tight, making sure the tube is all nice and tight. Taking your time to understand that can really help you troubleshoot problems. Lastly, the other problem you might have right out of box is this white tube. Unfortunately, it's kind of a cheap white tube. Now, there's upgrades to swap this around, but what you want to do is you want to take this clip off right here, and you want to make sure that this white tube is pushed all the way down in there. Remember we were talking about the tube and the filament going all the way through? Well, you can see that the inside of this, there's actually a metal tube in there, and then it comes through right there. This white tube actually wants to go all the way through that tube until it contacts that metal tube right down there. You don't want a gap in there. If there's a gap in there, filament's going to start to leak out. It's going to build up and not melt properly. And then you're going to have something called the nozzle blowout. And that is not fun. So you want to make sure that this tube is pushed in all the way. Now, if you don't have this white tube, you might have an upgraded tube on your printer already. This is a Bowden Capricorn tube. It's just a stronger PTFE tubing that doesn't back out and it doesn't wear down as easily. So this is probably something I would upgrade almost immediately, but that's a video for another time. So that tube's pushed all the way down. The one over here isn't as crucial, but as the filament comes through, it can wear it down a little bit. So again, you want to make sure that this is pushed in just all the way. Aside from that, our printer should be pretty much ready to go. So let's turn it on for the first time and actually get some filament loaded and get our actual first print going. Before you turn this on though, always make sure to check your power supply. I've actually burned a printer before because I didn't switch this. I live in England, so we use 220, 230, and I had this set to 120 voltage like the US, and it burned the whole power supply, and unfortunately it jumped the power supply and took out the main board. Make sure this is switched to your appropriate voltage, and then turn it on. So most 3D printer screens are basically going to display the same thing. What printer it is, this little symbol of your nozzle, and this little symbol of your heat bed. Now, not every 3D printer actually has a heated bed. This one does to help the plastic stick to it better, but it might not. And then you have your fan, you have your XYZ coordinates, and right now it has question marks because it doesn't know where the XYZ is. And then it has your feed rate, which how quickly you're printing, print time, and is your printer ready. This is the two-way communication I was talking to you about. That 0 right there is what the printer is telling these two wires and heat block to get up to. And then the 20 at the bottom is the ambient temperature in the room, 20 degrees Celsius. And that's what this little white thermometer is actually telling it. So this is that closed loop system of talking, and the same system exists on your bed. The bed's actually 20 degrees, and it wants it to be 0 degrees. Obviously, it can't cool it down, but like I said, that's just the temperature in the room. So your printer's turned on, and if you haven't already gone through and leveled it, what I want to stress is that these knobs, these adjustment knobs, lower them all the way, because if you haven't leveled your bed yet, you don't want your nozzle coming down and colliding into your bed and doing damage. Hey guys, so while filming and editing this video, a part of my data file got corrupted. So there's a little chunk of this video I'm gonna have to refilm. However, if you haven't already noticed, I've actually gone through and upgraded a couple parts of my printer already because I made another video directly after filming. So things are just gonna look a little bit different, but I'm gonna continue this and fill in this little part of the video that got deleted, and then we'll roll right back into the original shot, and I'll let you know when that's gonna happen. Like I was saying before, you wanna make sure that the adjustment knobs are as far down as possible. And then what you're gonna wanna do is once your printer's turned on, you're gonna wanna auto home the system. And it's gonna be a cool little feature in here. So you're gonna press and go to prepare. And then right there, you're gonna hit auto home. And now, just like we were saying, it X, Y, and then it comes all the way down to Z. Now if you look right there, you can see just how close this nozzle is to the bed. It almost looks like it's touching. I promise you it's not. I've already gone through and leveled this bed. The Ender 3 is very easy to level. It's a very small bed. Some printers in the settings themselves actually have a level corners option, and it'll be floating somewhere in here. And what it's gonna do, it's gonna automatically take you to each 4 of the corners, so you can put that little piece of paper underneath the bed, underneath the nozzle, and see just what your clearance is. And then it'll take you to the center of the bed to do the same thing. And you rinse and repeat that a few times until you have that clearance that you like. So I've already gone through and leveled this bed. I have that perfect little clearance. So now what we're gonna wanna do is actually load up some filament and actually test to make sure our bed is level. So before we actually put any filament in, we're gonna wanna heat the bed up and heat the nozzle up so we can actually get filament in here. But to show you what loading the filament looks like, I'm actually gonna wanna move this up a little bit, so as I push filament through, it doesn't drip and get onto the bed. So we're gonna actually move the Z-axis up a little bit, just so we have some clearance. So to manually move, all you gotta do is go to prepare, and your printer should have something like move axis or move nozzle, move gantry. And we want to go up on the Z axis. And then we can move our Z axis up. So let's move it up, I don't know, 50 or 60. And moving the Z-axis like this is the same way you're actually going to move your bed around to level your printer if you don't have that feature where it automatically brings you to each corner. So all you would do is you go to the X-axis, and then you can move the X-axis over a couple millimeters. So you can see it moving just like that, and that's me manually moving it with the controls. So I'm going to put this right in the middle. So you would use that, the X coordinate and then the Y coordinate to get the nozzle here, 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 and there. This way you can level your bed. So now we're raised up a little bit, and I can actually make sure that filament's going to come out of the nozzle. So now we're going to want to heat the printer up. We're going to want to heat the nozzle and the bed up to get ready for our first print. We're going to go to prepare, scroll down, and then we're going to preheat PLA plastic because that's what we're printing with for the first time. So you can pick if you want to preheat just the nozzle, the bed, or the hot end. So we're going to preheat everything and get everything warmed up and ready to go. So now you can see that the printer wants the nozzle to be at 215 degrees, and it's starting to heat it up actually pretty quickly. And then the bed's going to be at 60, and it's already at 25 degrees. Now there's a bunch of different settings and stuff that we're going to talk about in the software video about what you're going to want your filament to be at, what you're going to want your nozzle to be at, and different filaments and different colors require different temperatures. So don't really worry about what these numbers are yet. These are the numbers I use for the filament that I have, and we'll get into that in the next video. Okay, now our nozzle's up to temperature, so we're going to feed our filament in for the first time. Okay, so we're going to load our filament into our extruder for the first time. And what we're going to want to do is unwind our filament and make sure this doesn't sling back and get all tangled up. And we're going to want to pull it down. And if the tip of your filament is kind of bent or messed up, all I would do is I would take your cutters and cut it nice and flush. And then what I like to do when loading the filament is I'll actually take it and I'll try to straighten it out just a little bit because it just helps me push it through a little bit better. So get it as kind of as straight as possible. And then you're going to load the filament into the hole in the back of your extruder. And then you're going to hit a hard stop, okay? It's not going to want to go anymore. You're going to squeeze this little lever arm, and you can see it moving. And what that's going to do is it's going to actually open up that whole little gear system and allow you to push the filament through. Because there's the hole right here, and then there's a hole that leads all the way through this tube. Now there's a couple little steps in here. There's a couple little edges and lips. So if you're pushing this filament through and it's getting caught on one of those lips, just try to spin and twist it a little bit until it actually goes through this tube. So you'll see me doing that now, and typically it will get a little caught, and that's totally fine. Yep, so I'm caught, it's not going through. I'm just going to twist the filament a little, and oh, there we go. So obviously this filament needs to go all the way through this tube. So if it only gets pushed in an inch or so, you know there's probably an issue. So I'm going to go and actually manually feed all the filament all the way through. And if you pay attention right here to the bottom of the nozzle, you're actually going to see filament start dripping out from the nozzle once I get pushed this far enough in. So it'll go pretty easily right off the bat, and I'm feeding, and then eventually you're just going to hit a hard stop, and that's the filament going all the way through your heat sink into the hot nozzle. There we go. Wow, that came out fast. You can actually see the filament dripping out. Now you don't want to push too hard, just enough to make that pressure and start actually pushing the filament out. So we know our filament's all the way through, and it's dripping out black filament because that's what I had loaded before to test it. And now it's changing to a white filament, and it's already drying. That little fan's actually blowing on the filament as it's coming out and cooling it down basically as fast as it's coming out. You don't want to push on this little arm too much because you'll kink the filament, so just enough to push it and unlock that pressure. So there we go, our filament's good. Now while we're waiting for the printer to actually start and do our first print, what I like to do is I'll press this gear over here again, and I'll actually pull the filament out just a millimeter or two, just to relieve that pressure, or else this will just sit here and kind of drip out slowly. So remember, don't touch the nozzle, but you can clear away your plastic. So there is a little bit more of an electronic way to do this. Remember how we were moving our axis around, we were moving our X, Y, Z around manually? If you go into prepare and you go to move axis, you can actually see right here, it says extruder. And what this is gonna actually do, it's gonna spin that little extruder gear and push filament into the hot end and through the tube. Now, I don't particularly like doing that way because if it starts to get caught on any of the lips right there, you won't really know. So I always like to manually feed. You can manually spin this to 20, 30, 40, however much filament you wanna push through. You can actually see this gear turning very slowly, and it's pushing filament out from my nozzle. And I can actually let it, as I pull it out, it'll dry. And I can make little shapes and swirls. So again, if you're doing this, don't touch that nozzle. And then once it's done, it'll stop extruding and you'll be able to start your print. And then we can click and back out of this. Okay guys, So that does it for the little bit of the video that was deleted. We're gonna jump right back into the other roll and we're gonna continue talking about filament and we're gonna get ready for our first print. So our filaments push through and make sure this doesn't unwind too much. You don't want this sitting out. Just try to get it nice and snug. Now some printers actually have a sensor that sits a little bit farther out. And they look something like this. They might be plastic or metal, and this is a filament runout sensor. So it's just something else you actually push the filament through, it'll click, and it lets the printer know when it ran out of filament. The Ender doesn't have this, so if it runs out, it'll just keep printing in midair. A printer like this, or a CR10S, will actually pause the print until you load more filament in. Actually, I have one of the sensors right here, and the filament goes through one side, triggers, and comes out the other. You can also upgrade some printers and add them, but we're not in that yet. Our bed's nice and warm, our nozzle's heated up, our bed's heated up, everything's ready to go, we're level. Let's try our first print. And your printer probably came with a little SD card or SD card slot, and it's gonna have some predetermined prints loaded on it. So depending on where you need to put in the SD card slot, on the Ender, it's right down here, and it's the only printer I think I've ever used where the SD card goes in one way. So click it in, we're leveled and ready to go. So it says no TF card. We're gonna go down to initialize TF card, and then we're gonna go back up to print. And right there, this is one test Benchy loaded in there. I think on the stock printer, it comes with like a dog, a boat. I think it comes with a cool little Buddha statue. We're ready to go. We have filament, let's hit print. So now, depending on what you put your settings to, the printer's gonna adjust what the temperature was on that print. So I didn't have this exactly set. It wants my bed to be at different temperature. So actually it's gonna go through and change that now. It wants the bed to cool down just a little, heat up just a little bit. So we're gonna let the bed catch up to the temperature I had programmed, and then it's gonna start printing. If there's a time to watch your 3D printer, it's your first layer. It is the most important layer. If your first layer doesn't go down good, your print's not gonna come out. And that is a very good indication if something's wrong. Is your filament actually getting pushed through properly? Is your bed level? An unlevel bed will make this print come out not good very quickly. So now we're at temperature and it should start any second now. And there it goes. So it's gonna auto home by itself, but it's always a good idea to just do it manually. Depending on your printer settings, it's gonna start pushing through a little line of filament called a prime line, and you can see the white line right there, and it's going to make sure there's actually filament coming out before the print even starts. So it's going to move to the center of the bed, and you can see it start printing just like that. Now, I'm very good at leveling beds, so this is going to come out pretty good right on the first spot. Now, if there was no filament coming out, your nozzle's too close. And if your nozzle's too close, what's going to start to happen is you're going to start hearing a clicking noise coming from up here. And actually, I might be able to simulate it if so if I push up, nothing's coming out. And if I actually push the bed down a little bit, the filament's actually too high now, so it's not sticking as well. So again, that first layer is a real good indication on what's going to be wrong with your printer. What you'll see with white filament is it'll always come out transparent or almost like glass if your nozzle's too good. White filament's really good for dialing in and calibrating your printer, because typically your bed's going to be black or glass, and you can actually see the white filament very nicely. So this is that prime line that it's dry and I can peel that off. I don't know, there's something therapeutic about peeling this off when your print starts. So if your bed's not level right, the print will start to come out kind of weird. That's fine, just recalibrate it. Now say this print is coming out like dookie, and we want to get rid of it. And that's what we're gonna do. We're gonna stop this. Imagine if this was just going bad. So you can actually go into your settings, and you can do a few things here. You can adjust the temperature of everything, but you really don't need to do that yet. Or you can pause the print if, say, you want to change out filament, or you just don't want to leave it running overnight, or you can just straight up stop the print. So when you stop the print, it's going to stop heating everything, but we want to make a print go again, so we're going to immediately go back in and we're going to preheat the filament in the bed again. But I want to move this bed around again, so make sure you go back in and you disable your steppers. So I'm going to disable them. I'm going to spin this gantry up just a little bit because I don't want it colliding when I move it, and now I can pull this out. So that was actually sticking pretty well, even with me trying to mess with it. So let's peel this off. Let's peel this off. So that was some pretty good adhesion. Adhesion problems are a nightmare. There's just so much information out there. I like this fiberglass bed. Things stick to it really well. Glass beds can be kind of problematic. I swapped out all my glass beds. You don't have to. There's ways to use glue sticks and hairspray. The magnetic beds, in my mind, are the best ones. It's a combination of this fiberglass kind of surface, and they're just nice and removable and easy to deal with. You can wash these down with soap and water. Sometimes what I'll do is I'll take a piece of Scotch tape and I'll actually wipe the glue side of the tape on the bed to give it more of a tack. And temperature and settings matter a lot, but that's going to be for the software video. So again, we're back to temperature, and without moving anything, I'm just going to start the print again. Okay, everything's zeroing out and the print's starting again. Now the line should start a little bit sooner this time because we know there's filament in it and it's good to go. And we're off, folks. We're 3D printing. So everything's level, everything's built. Another suggestion I might make right out of the box is, even if you didn't build that particular part, even if you didn't tighten all these bolts, they came from the factory like that, check them over, make sure everything's tight. Again, there are a couple manufacturers that make these things, and you just want to make sure everything's nice and snug and tight. The same way that this nozzle could have been loose, there's that same type of concentric nut right there. And what this can do is that these bearings can be loose and the bed can droop a little bit. So just go through, make sure everything's nice and snug, and you'll be off 3D printing in no time. So our print finished, and this is what our Benchy ended up looking like. And this is a really good calibration test just to see if your printer is working properly. It has little overhangs and arches, it has circles, it has some detail and ridges, and there's a guide for calibrating your printer based on how this entire thing comes out. It's a really cool little, just a really awesome little test. And there was some stringing, and so I actually used a lighter to kind of get rid of some of it, and it left some black marks, but that's fine. And I'll put that in the description below. Calibrating your printer with a Benchy, and this is a good way to tell if your printer's coming out good. And depending on the quality of these, you'll know what you're gonna have to change and adjust.
All right, guys, I think that's it. I know that was a lot, and it kind of needs to be. I don't want to be the person just to tell you, do A, B, C, done, and you'll get a perfect print. I want you to understand what's going on with this. I want you to understand what's actually happening with the printer, because it's just gonna make so many things that much easier, especially when we go into the next video about software and settings, and we're talking about different infills and densities and speeds. How everything moves and operates will make a lot more sense, and it all will come together when we actually get to printing this thing. So in the next video with software, we're going to be actually looking at this, making our own file instead of using the little test prints, and we'll actually be orienting this into different positions, learning the software, learning how to cut it up and actually make our own print. But we know now that our printer works, it's good to go. And when we're talking about different filaments and plastics and colors and materials and temperatures, that's more on the software side. Like always, if you guys have any questions, comments, concerns, critiques, drop a comment, message me on Instagram. That's totally fine. Again, this is going to be an ongoing series. I know there's a lot more I can cover on the printer, upgrades and repairs and common troubleshooting. That's another video. I actually have a lot of upgradable parts for this ender that's going to be in a video in the future just to make it work a little bit better. But out of the box, it works just fine as it is. So thank you so much for watching, guys, and make sure you go check out the software tutorial as well so you can understand more on how to get this, and we can actually start making the big things that we want. If you haven't subscribed already, please do. It'll help me out a lot, and I really appreciate it. And again,